everyone, in this video we're going to go through the solutions to the multiple choice test. So let's make it a quick video because 25 questions and you know I like to whiffle waffle as someone said, although I do agree. So let's get onto it. Alright, so question number 1. At the point 2, 0 on the graph of the function y equals negative x plus 2 squared. So we just want to know what is happening there. So it is a local minimum. Now, if you were unsure, you could just graph this on your calculator, but the negative sign inside, this negative here, just means it's been reflected along the y-axis, which makes no difference because you're actually going to be squaring it. So we've got a local minimum there. So if you're unsure, you could graph it, but remember in an actual exam, you want to be saving time. So things like this, you have to have confidence in what you're doing. And if you wanted to check it later, just put a little C next to the question so you know how to check it with your calculator. All right, the smallest positive value for which cos 4x equals 1/2 is. All right, so this is where you need to know your exact values. So inverse cos of 1/2 is equal to, let me just check, pi on 3. So we're going to let 4x equal pi on 3, and then we're just solving for x. So it's going to be pi on 12. So something you could also do on your calculator. How would you do this on your calculator? I'm just trying to think. You could, let me just show you because I'm thinking as I'm doing it. Oh, where's my calculator gone? There you are. All right, so you could just do solve. Let me get rid of all that other stuff. Clear all. All right, so if you want to ever solve something, oh, why aren't you working? This is really annoying. Ah. All right, clearly it's not working. If you want to solve a cos function, you don't want a general solution, just restrict your domain. So that's what I was going to show you. I might have to get that calculator working in a sec anyway for another question. All right, so question number 3. If y equals a to the power of 2x plus 3b, then x is equal to, so it's just rearranging your equation. So maybe I can do that. My dog is barking, but sometimes I don't think you can hear what is happening outside. All right, so we want to solve for x. So we're just going to put 3b onto the other side. And then we're going to take log base a of both sides. So that's equal to 2x. And then x is equal to, so divide both sides by 1/2, which is the same as multiplying by, divide both sides by 2, which is the same as dividing, start again. Divide both sides by 2, which is the same as multiplying by 1/2. So log base a y minus 3b. All right, which is C. All right, the graph of y equals kx plus 4 intersects with the graph at 2 distinct points 4. So, all right, we're just going to let them equal because we've got y equals and y equals. So we're just going to solve their point of intersection. You know, I usually do videos at night because, you know, obviously working during the day. And that's when the possums come out and that's when my dog likes to bark and disturb me. All right, so you can see, oh, look what's happening. We're going to start having a quadratic here. So we've got x squared plus kx minus 10x plus 4 equals 0. All right, and so we just use the discriminant. So it means we've got to get our a, b, and c. So a is the coefficient x squared. B is your coefficient of x. So we just can take out k minus 10 as a common factor. Sorry, we could take out x as a common factor and left with k minus 10. And then c is equal to 4. So your discriminant has to be greater than 0. And I'm sneakily looking at my page while I'm doing this. So b squared minus, what is it? B squared minus 4ac is your discriminant. And you do get k equals 6 and k equals 14. So we want it to be less than that. So when you're checking whether, whether you're greater than or less than 6, just draw the quadratic. So this is a positive quadratic, all right? The coefficient here is positive 1. So it's going to look like that. So our first point of intersection, oh, it's not going to look like that. It's going to look more like, that was a positive parabola, but my intersections are on this side. All right, so there's your 6 and there's your 14. So this is the graph of your discriminant. So if we want to be greater than 0, just make sure we want 2 distinct points. So it's going to be less than 6 and greater than 14. Another way you could do it is just substitute in a point between 6 and 14. So let's say 10, and just see whether your discriminant is greater than or less than 0. All right, so those types of questions are often on exams. Question number 5. So I am referring to my original notes here, just to make sure I don't miss anything. So here we've got a composite function. So these are usually done quite well. You could actually just define both of these functions, but sometimes it's just easier to do things by hand. And because my calculator's not cooperating, we're going to do it by hand. All right, what are we doing? F of g of x. Why am I doing? All right, I don't need to write it. So square root, and then x, we've got 2 on x, and then minus 4. So we just take a quick squiz, see if that's anywhere. Now, I can already see what we could probably cancel. So it looks like it's not going to be E or B, just because of the way it's written. And don't think, oh, maybe I just got my negatives around the wrong way, or I forgot negative or something. Have faith in what you're doing. So I can see these other options all have a common denominator of x. So that means I can rewrite, well, I can write 2 over x is 2 over x, and then 4 can be written as 4x over x. So then I can bring them over the same denominator. So 2 minus 4x over x, and that's under your square root. So that is going to be option A. All right, your general solution to cos 2x equals -1. All right, so you could easily do this on your calculator. Sorry, I had to pause for a while because, I had to chat to my son. So inverse cos, let's just say we didn't have the calculator, of -1 is pi. So we've got 2x is equal to pi. So x is equal to pi on 2. Now with your general solution, this is how you can remember it if you don't have your calculator. So cos is negative in, where are we? This quadrant and this quadrant here. So we're going to be doing pi. So here we're going to be pi minus pi on 2 and pi plus pi on 2. Sorry, doggo's barking. So with your general solution, we can keep obviously going around and around our unit circle. When you think about it, this pi on 2 is actually 90 degrees. So we're actually ending up here and here. So if we're putting n in, so if we put in n equals 1, we're going to end up with one solution being pi minus pi on 2 and pi plus pi on 2. If n was equal to 2, we would end up with 2 pi minus pi on 2 and 2 pi plus pi on 2. And you're probably thinking, well 2 pi is over here, and I don't know why I'm going on a tangent here, but cos is positive in this quadrant and this quadrant. But what we're effectively doing is 2 pi minus pi on 2 is ending up at the same spot as pi plus pi on 2. So your correct answer for that one is D. The easiest way would be just to do it on your calculator. All right, so I just opened it up again. Let's go to solve, and we're doing a trig. Just quickly do it. Cos 2x equals, I can't get the sign. Yes, -1, comma x. And just make sure we're in radians, yes. All right, now it's thinking. It's probably going to disappear. Oh, there we go. Pressed it twice. So remember the const n, 1 is just, you just substitute with n. And then constant 2 is just another constant. So just replace that with n. Okay, so you can see exactly the same thing here as on the calculator. We've just replaced that const n with the letter n. All right, sorry, I went on a bit of a tangent there. All right, question 7. For the function f of x equals negative x squared x minus 3, the subset of R for which the gradient of f is positive is, so here we've got a cubic, so we can graph that. Let's do that on the calculator. Gosh, what am I doing? Menu. Oh, let's just clear everything. All right, so negative x squared times x minus 3. And then just, can we get, I'll just tick that. All right, so we want the gradient to be positive. So I can see the gradient is positive between our two turning points in this center part here. So all I need to know is those turning points. I can kind of see off the graph that it's going to be from 0 to something. So I can cross off this one, and this one, and then just see on our calculator, if I just go to maximum. All right, it's going to work for me. All right, there it is at 2. So between 0 and 2, it is a positive gradient. You could also do the derivative if you wanted to, and then you could have a look at the derivative there. All right, so what do we got? The derivative of f of cos 2x with respect to x is, so this sort of notation is interesting. So the derivative, so if we've got f of x, then the derivative of f of x is f dash x. Now we want the derivative of f of cos 2x. So that's kind of using the chain rule. So we're going to let u equal cos 2x. So du dx is equal to negative sine, whoops, not negative sine, negative 2 sine 2x. So your derivative is going to be your derivative of f times the derivative of cos 2x. So what order have I put that in? So we're going to do negative 2 sine 2x first times f dash, and it's not x, sorry, I should have put u, so f of u, my bad. Let's just put that back in. F of u, which was cos 2x. So the answer for that one, where is it? Negative 2 sine, was it C? Let me just refer to my notes. Yep. All right, so that sort of notation you do see, and it's just, you've got a function and you inside a function. So we're going to be using the chain rule, right? It's just a little bit different. You know, it's kind of, if you were using, say if you were doing log of cos 2x. All right, so you've got a function inside a function. You would just use the chain rule. And I think that was a question on maybe a short answer. All right, the tangent at the point 2, 4 on the graph of the curve f of x has the equation y equals 3x minus 2. The tangent at the point on the curve y equals f of x minus 2 plus 1 has the equation. All right, so this is actually a past exam question, and I don't even think I changed the numbers. So let's have a look at how it's done. So if we're going from 2 to 4 to 4, 5, what are we actually doing to those points? So our x, all right, is we're adding 2. And to our y, we're adding 1. All right, so they're the transformations on our point. If we were to write that in function notation, it would be x minus 2. All right, so there's our translation. Our horizontal translation, and then our vertical translation. So basically everything has shifted the same. All right, so our gradient is the same. All right, it's just our y-intercept that has changed. So we're still going to have a gradient of 3, and we've just got this new point. So 4, 5, so 5 equals 3 times your gradient, 3 minus, not 2, sorry. Actually, I'm not even doing that one right. Why did I substitute in? Oh, what am I doing? Not 3, 4, all right, because x equals 4, sorry, plus c. So c is equal to, oh, what is that, -7. All right, so your equation is D. So a bit of a tricky one, but I like that question. And I guess the thing that you needed to notice was at this point to this point, the transformations is the same as what's happened to f of x. All right, so that means the tangent has just shifted, but the gradient is the same. So you've got a new y-intercept, you've just got a new tangent. So the two tangent lines are parallel to each other. That's why your gradient's the same. All right, question 10. The function f has the rule 3 log base e 3x if f of x squared equals blah, blah, blah. All right. So we've got 3 log e 3. So, what am I doing? X squared. And that is equal to log base e of y. So we just need to rearrange things to get both sides in log base e, basically. So this 3, all right, using your log rules can become the power there. So 3x squared to the power of 3. All right, so we can take base e of both sides, so then we're just left with y on this side, and then this side, let's just do everything to the power of 3. So 3 to the power of 3 is 27, and you could actually do this maybe on your calculator, I'm not sure. So y is equal to 27, x to the power of 6. All right, the function with the rule will have an inverse function for, so here we have a truncus. So think about what is happening to this truncus, or even what this truncus looks like. Let's have a look at what it looks like. Oops. All right, so we've got 1 on x minus 3 squared plus 4. All right, so we can see there's an asymptote at x equals 3 and a horizontal asymptote at y equals 4. So this is a bit of a trick question. So we want to do an inverse. So it has to be 1 to 1. So if I do a quick, I'll just talk to the graph. Okay, so if I was, so basically the domain for the graph is any real value excluding 3. All right, that's the domain, but we want it to be 1 to 1. So can't be r, because that's not going to make it 1 to 1. R negative, so we want all negative real numbers, and I can see, if I just drag this over a little bit, you can see all those values that are negative x are not 1 to 1. All right. Sorry, they are, what am I talking? They are 1 to 1. So we can only have R negative. Let's have a look at the others. So R positive. So if we looked at the positive side of x, you can see it's still not 1 to 1. All right, because we've still got 1 to many. So if we have a look at the hyperbola, as we get higher, you can see there's 2x values for some y values. And then r excluding 0 is still going to include all real values, and same with 3. So it has to be r negative. So a bit of a trick question, because you had to realize that inverse had to be 1-to-1 functions. So we can only take r negative. All right, I feel like I'm delirious and not talking properly, so I apologize, but I'm going to persevere. All right, so the graph of the function where D is a maximal domain has asymptotes. So again, if you're unsure, just graph it. So let's graph it. All right, so keyboard, all right, x minus 3. Sometimes it's good to show you how to do it on the calculator too, because sometimes the calculator doesn't show things really well. So learning how to change the calculator is good. Now, first of all, this looks like it ends down here, but it keeps going. It's just not showing. So we've got 2 asymptotes. Now, I know that already that my denominator cannot equal 0. All right, so it's undefined. So x cannot equal 2. So we've got an asymptote at x equals 2. So that's going to cancel out 3 options, which is pretty awesome. All right, so we've got to choose between -1 and 1, and I can clearly see it's going to be 1. Where are we? So D. Actually, sorry. -1. What am I doing? I was looking at the wrong spot. -1. So the answer is C. Here I am saying clearly. I was looking at the wrong side of the graph. All right, so x equals 2, y equals -1. Now, if you're unsure, let's say we didn't have our calculator. All right, so we've got x minus 3, 2 minus x. So the way to work out what your asymptotes are going to be, all right, so we know that our denominator cannot equal 0. So that one's easy for our vertical asymptote. For our horizontal asymptote, think about, well, what's going to happen to this when x becomes really, really big? So as x gets bigger and bigger, all right, basically the -3 and the 2 become negligible. They're so small in comparison to the x. So x over -x is -1. So on your graph, if you can see, it's hard to, I mean, I've done this in class, but as x continues to approach infinity, all right, it's going to keep getting closer and closer to -1. So let's say x was 1 billion. All right, so your numerator would be 1 billion minus 3. So that minus 3 is very small compared to the 1 billion. So that's why I'm saying it's hardly worth acknowledging. And the same is if you did 2 minus 1 billion. All right, the 2 becomes irrelevant. So we just do x over -x. So it's negative. That's how you get the -1. All right, question 13. The graph of the function, so we're domain from 0 to infinity of 3x to the power of 5 on 2 is reflected in the x-axis and translated 3 units in the positive direction of the x-axis and 4 units in the negative direction of the y-axis. The new graph is, okay, so what are our transformations? We've got a reflection in the x, so that tells me we're going to have a -3 out the front. So that's going to get rid of that one and that one. All right, then we've got 3 units in the positive direction of the x-axis. So we want it to be -3 inside our brackets. So it's not going to be that one or that one. And then it's gone down, has it? Yeah. So our only option is B. I should be checking my answers as I go along. All right, moving along. So question 14, I took from the sample exam. So there's not any trapezium questions on past exams because it wasn't on the study design. We did rectangles, not trapeziums. So for this one here, you just use the trapezium formula like we did in class. So I really can't be bothered doing it, to be honest. So I hope for this one, you just use the rule. So half a, what was it? half a plus b times h. So they should all start with a half, which is great. And remember, these points are shared twice. So that so the points in the middle are included twice. So they're multiplied by 2. So this first point, we just want 4 to be appearing once. So it's not going to be C, D, or E. And then the last point we want once. All right, so, and then I can see the main difference is this point here, which is at 1. So 1 times 2 is 2. So it's got to be B. I might just check my answer because I don't have it on my sheet. Yep, B. So that's how you can do it quickly. You don't really need to use a calculator. It's just a process of checking the features of the trapezium rule. All right, question 15. Let's have a quick sip of water. All right, so your period, I think there were 3 period questions on this SAC, so 1 for each section. All right, so your period for a sine function is 2 pi on n. So your n is your coefficient of x, which is pi on 5. So for this one, if you couldn't do this division, you could do it on your calculator. So 2 pi divided by pi on 5 is the same as multiplying by its reciprocal. So those pi's cancel and we're left with 10. All right, so ones like that should be a gimme question. It should be 100%. All right, question 16. Let me just see where I'm up to in my notes. Don't know whether I've done this one or maybe it's a new question I brought in. Okay, let's just see how we go. The normal to the graph of y equals b minus x squared has a gradient of 3 when x equals 1. The value of b is... All right, so your normal, remember, is related to your tangent. I'm going to just do it in pink. Okay, so your gradient of your normal is 3. So the gradient of your tangent is the negative reciprocal, so negative 1/3. So let's also do the derivative of y equals square root of b minus x. So y equals b minus x squared to the power of a half. I'm just thinking whether there's an easier way to do this because I haven't got any notes on this one. All right, let u equal b minus x squared. So du dx is equal to, so the b goes negative 2x, and then dy du is equal to a half u negative u, half u is b minus x squared to the negative a half. All right, so dy dx, I'm going off the page. All right, so that negative 2 and that 2 cancel, so then we're just left with x b minus x squared to the negative a half. All right, so that gradient should be equal to this, sorry, I should say, this gradient is equal to this. And we've also know that x is equal to 1. So let's do all that on our calculator. There's a lot going on there. Main screen. All right, so we're going to go to solve. So negative 1/3 is equal to x times. Now I know that. Oh, I'm going to put. Yeah, I knew that was going to happen. I know x is equal to 1, but for some reason I put it in there. So x squared to the power of negative a half. God, I'm really going the long way about it, aren't I? Comma b. So we're solving for b. Sometimes it, yeah. Now, I could do given that x equals 1, but let's just go back and change. So that's going to be a 1 there. All right, just to make sure I've got that all written correctly. What have I done? All right, so I forgot this negative. So there's a negative here. I forgot to put it here. I think I said it. I remember it. Yeah, anyway. All right, so I've just changed it on the calculator. Put that negative in. So B is equal to 10. So a bit of a tricky one, I think, that one. But whenever you see anything to do with a gradient, remember there are multiple ways of finding the gradient. So one way being your derivative. The other way is your tangent, or in this case, your normal, which is also related to your tangent. Or you could use the concept of tan theta is equal to opposite over adjacent, which is rise over run. So there was nothing like that on this exam, but you might see that in past exams, and you could see it this year as well. All right, let's keep going. Question 17, a cubic function has a rule y equals f of x. The graph of the derivative function f dash x crosses the x-axis at 2, 0 and negative 3, 0. The maximum value of the derivative function is 10. The value of x for which the graph of f of x has a local minimum is. All right, so let's think about what this is asking us. The graph of the derivative. So if we've got a cubic, then its derivative is going to be a parabola. So it's crossing the x-axis at 2 and negative 3. The maximum value of the derivative is 10. So there's 10. So your parabola is going to look something, oops, not like that. Sorry. Let's try that again. Oh, that's really bad. It's because my scale's out. But there we go. It's all a rough sketch. We're not an art class. So it's a negative parabola. So the value of x for which the graph y equals f of x has a local maximum. All right, sorry, I just had to think about what I was doing. So this is your graph, your derivative function. So remember, this is the graph of your derivative. So when we want a local maximum, so we got to think about, well, what's happening with the gradient? So here it's going to be negative, all right? So we're below the x-axis, and then here, oh, I do it in green. And here we're above the x-axis. So when I sketch my cubic, all right, my gradient is going to be negative, and then, so at negative 3, we've got a turning point. So it's going to be negative, and then it's going to be positive. So at negative 3, we're like that. And then for 2, you can see it's, sorry, I did it around the wrong way. Sorry, guys. All right, it's negative. Oh my gosh, what am I doing? It's negative, and there's your turning point at negative 3, and then it becomes positive again, and then at 2, there's your turning point, and it's coming back down. All right, so this part here from negative 3 to 2 is positive. All right, just wanted to show you that. And there is your negative, and there is your negative. So the question is asking, where's your local maximum? There it is at 2. Oh my gosh, I should really stop. But we'll keep going. All right, so consider f of x equals x squared plus p over x. There is a stationary point on the graph of f when x equals negative 2. The value of p is. All right, so I was just thinking about this, and let's just approach it. So the stationary point, so is when you got a derivative. So when your derivative is equal to 0. So let's find the derivative first. So we're going to have 2x. And then x to the negative 1, so it's going to be negative px to the negative 2. All right, so we've got a stationary, so let's let that equal 0, sorry. All right, so f dash, was that negative 2? All right, so let's substitute in negative 2. You could actually do that on your calculator, but look at me, I just really can't be bothered getting my calculator. Oh, probably will now that. Oh, let's just quickly go. 2 times negative 2 is negative 4. Negative 2 to the power of negative 2. So 1 on 4, negative 1 on 4 plus p on 4 equals 0. P on 4 equals 4. So p is equal to 16. Let me just do a quick check. 18. No, I got the wrong answer. Where did I go wrong? All right, there's my mistake. So negative 2. So that is 1 over 4. And I thought it was negative 1/4. So that makes this a negative. All right, which will then give you the negative 16. So yeah, if I did that on the calculator, I wouldn't have made that mistake. There we go. So just a little, reason to use your calculator. For the function f of x, the average rate of change with respect to x over the interval. So average rate of change, remember, is just your gradient. So we're going to have f of, it doesn't really matter what order you do it in, but 10 over 3 minus 1. All right, so then you can just do that on your calculator. I'm just going to be cheeky and rush through this one because it's a bit easy. B, so you're just substituting in 3 into f and 1 into f. Yeah. All right, question 20, the simultaneous linear equations have a unique solution. Oh, wow, I love these. So we want a unique solution. So you can rearrange them in the form y equals mx plus c and make sure you don't have the same gradient and y-intercept. But I love just doing the ratios. So we've got m over 7. All right, so the coefficients of x over the then the equal to the coefficients of y. So for this one, m is 7m. What am I doing? So m squared equals 49. So m can equal plus or minus the square root of 49, which is 7. All right, so that means m can be, so if it was equal to 7 or negative 7, we're going to have the same gradient. So it can be absolutely anything other than 7 or negative 7. So our answer for that one is C. So it can be anything other than 7 or negative 7, because when it's 7 or negative 7, you're going to have the same gradient. All right, question 21. I love these ones too. So your derivative is equal to 3x squared minus 4. Which one of the followings is your original function? So we've got a parabola, so your original function has to be a cubic. So let's just do a process of elimination. Can't be that one, can't be that, or can't be that. So we're just choosing between B and D. And this is actually a past exam question because as if I'm going to be drawing those graphs. So the other thing we need to look at is with this graph, all right, 3x squared minus 4. What does that actually look like? So 3x squared minus 4. So it's a positive parabola that's going below the axis. So that means it's got 2 stationary points. So it has to be B. You don't even have to find the antiderivative and then sketch it. These sorts of questions you should be doing very quickly. All right, eliminate which ones it's not, and then think of features of your derivative which tell you what that tells you about your original function. All right, nearly there. All right, so we've got f of, now we've got some definite integrals. So we're going from -3 to 2, 2 to 3, and -3 to 3. So we want 3 to -3. So let's look at this on a number line, what is actually happening. So our first definite integral, so just take note of your terminals. So make sure we're going from lowest to highest. If not, you've got to then change things around. So yeah, there has been past exam questions like that. So we'll do some before your next exam. All right, so from -3 to 2, that's negative 8. And then from 2 to 3, that is 10. So we want to go from negative 3 to 3. So we've got negative 8 plus 10 is 2. So 22a. Now, remember your definite integrals are not the area. All right, so you can have a negative 8 there. Yeah. All right, question 23. The maximal domain of the function g is, so you could sketch this, which is probably what I'm about to do. All right, let's clear everything. What have we got? So on your calculator, ln is just your natural log. Oh, it doesn't like it when I press it. There we go. Negative 2x. Oops. No, I don't want you. I want the button. I want that button. Sorry. Let's. Oh, I don't know where. Oh. Try again. It's so annoying that it's below here. I could open up my keyboard. See if that's going to help. Can I write that there? No. Sorry, guys. Oh my gosh. All right, there we go. Ah, now it's not letting me press it. Come on, guys. All right, finally got it working. So there it is. So we want the maximal domain. So we can see what's happened with that graph. It's been reflected along the y-axis. So your log actually can't equal 0. So it's only going to be r negative. Here's your answer. And that one there, if you understand your transformations of log graphs, would have been a quick one to do. And remember, you can just put a little c. You can come back and check it on the calculator. So with your exam at the end of the year, a lot of questions can be quickly done without a calculator and then just checked later. Because if you're like thinking, oh, I think it's this, but I might just double check on the calculator, that double checking is going to cost you time. So just do a little c and then you can come back to it. All right, 2 to go, guys. All right, the range of the function blah, blah, blah is, all right, so these are typical questions as well. So we've got a parabola. Good luck trying to graph it. All right, you're going to cooperate. So x squared minus 2x minus 8. All right, let's just graph that. There is another way of doing this, but I'm just going to show you on the graph. Oh, sorry, I thought I did check it. Okay, so there's your parabola. Now we've got this restricted domain, which is always there to make sure that you understand what the domain means. So what you can do on your graph, you can just say, all right, I'm going to restrict that domain, guys, given that x is between -2 and, oops, just need to go back and use the right inequality sign too, not like I was just about to. 3. So let's graph that again. Hello. All right, so you can see there that we've got that turning point. So when we're doing our function, so we're doing the range, so we want the minimum first. Yeah, of course you're not going to work, are you? All right, let's try it again. Function min. Oh my gosh. Try it one more time here. There we go. All right, so it's at -9. Now that is included, all right? It's on the graph. So we can cross off A, B, C. So it's got to be either D or E. So let's go back to our graph. So we're doing the range. So we're going between, our choice is between 0 and -5. I can clearly see it's going to be 0 because we're doing the y value. So you can see how it stops there on your x-axis. And at that point, that's at -2, so it's included. So your answer is D. All right, lucky last, guys. All right, if 3 times f of x equals f of 3x, then the rule of f could be, so this one here is just a quick, just doing it, oh, and it's actually A, which is pretty cool. So let's just do option A first. So 3 times 3 of x is 9x, and then f of 3x, oh, excuse me, didn't realize I was getting emails, 3x is also 3 times 3x, which gives you 9x. Imagine that, ending on an easy one, guys. So it is A, but if you wanted to test the rest of them, so the next one is going to be 3 root 3x, and then f of 3x is going to be square root of 3 times 3x, which is square root of 9x, and they're not the same thing. All right, so I could go through and do each one, but option A is the correct answer, which is cool because we don't have time in the exam to check the rest. All right, bye girls.